Hi, welcome to Elevate 2021. This is Thomas Rolseth with Intertech Consulting. And I'm going to be talking about document management with the .NET Data Store. Here's our usual disclaimer. And the session agenda today, I'm going to be talking about uploading documents to the database, which in this case is SQL Server. There's kind of two parts to the actual file upload. One is a standard way of doing it with large files over 10 megabytes, and this utilizes kind of almost a web form upload technique that's pretty common. But in the cases where we're dealing with files that are smaller in size, you can also utilize and make use of the JSON package object. And this is kind of slick because you can take a binary file and encode it and put it into so this gives us a couple of different ways of doing things. I'm going to also demonstrate and talk about retrieving documents from the database. And this is exclusively going to be using the JSON packager to pull files down using the PB blob data type. I like to use a kind of what I call a broker data store. It's an external data window that I can use to populate with data and send it back and forth across the wire. I mentioned the PB blob data type. This is something fairly new to SnapDevelop. And it's kind of a slick way to create a document that you pull out of the database and send it back to the client. I'm also going to be talking about emailing these documents that we're going to be using with a tool called MailKit, which is something that you can get from NuGet and add as a reference to your .NET solution. These techniques shown can be applied to any blobs that need to be streamed effectively to the middle tier. Again, my name is Thomas Rolseth. I've been with Intertech since 2017, working on a variety of projects, initially involving EA server migrations, and that's kind of led us to more work with the SnapDevelop API, which is kind of a key area that I work with Intertech on and their various clients. Here's a slide about Intertech Consulting profile, partners with a lot of different organizations: PowerSoft partner, Microsoft, Sybase, SAP, Appian, of course, focusing on architecture, consulting, programming, and project management. So what is the business problem? Why are we talking about document management here? Well, Intertech has a client, a long-term client with an old legacy Power Builder application. The client is a branch of the Department of Justice with many users spread across the country that use this application. And a big part of it is managing documents, generating new documents, filling out forms, retrieving them, deleting them, whatnot. And they're generally Word documents, PDFs, and this is all key to their casework. The uploading and retrieving of these documents was slow, and a 10 megabyte cap was placed on the document size because of that. And right now it's all embedded SQL. And by that I mean in the Power Builder code, they're either doing a select blob or update blob, depending on what the user is doing. And often they have to wait a fairly long time for that process to finish. So what we propose to the client is to take their existing way of doing it and porting that to SnapDevelop, and putting that logic at the middle tier in the hope of improving their performance. To do this, we built a proof of concept application, which is what I'm going to be demonstrating today, to validate the approach. And we're getting close to essentially using this POC to show to the client, get their sign off, and then do a kind of a full implementation after that. This is some screenshots from their legacy application. The application is called Enforce. The first screenshot is a simple window that they use to upload and retrieve documents. There's three buttons in the lower right. One is to insert a new document, another is to open an existing document, and then the third is to delete a document. Pretty straightforward in terms of the UI. The second is another screenshot from the application that allows them to generate forms using a lot of the same functionality, and by that I mean embedded SQL to do update blobs, select blobs, writing using the file write and file read to do various things, and also they use Olay to open the document in place. And the third screenshot is a PDF form generated from this process that can be opened and accessed in various parts of the system. As I said, we built a proof of concept, which is kind of the focus of my presentation. What you see here is a screenshot of the interface, and it has several buttons on it that do various things that I'm going to walk you through. One is to upload, insert document. Another is to retrieve, with the added functionality of emailing a document using MailKit, deleting a file, just some display options, different ways of viewing the document once you pull it out of the database. And so I've implemented a web browser control here, along with the existing Olay activation in place. And then just a simple MLE window or box to show and capture API response codes and text and so forth, just to help with error handling and validating that things are working as they should. So the middle tier is now an Enforce. Is a REST client API that's called Enforce API. I've got a representation of the solution here on this slide. Just to point out, the database again is SQL Server, and when I run this in our proof of concept application, it's actually hitting a sandbox database on a remote server. And the API itself is hosted on an Amazon AWS instance that I created and set up. I like to do that. Just I find it good to deploy things on remote servers, kind of to replicate a production environment. So the first part of this is what I want to show you in the demo that later on in the presentation is inserting a file. On the client side, you'll see some code here that's probably looks familiar to some of you. I'm creating a data store and a JSON package, and from that I'm taking a blob that's been passed in, and I'm encoding that with a base64 encoding, and then inserting a row in my data store and assigning a document ID, the name of the file, and the encoded binary data. And and then finally, after doing that, we create a JSON package and give it a key name of document data and pass along the data store. And then that ultimately is passed up. A REST client call is made to the API using the submit method. And here you can see the last line of code. I'm just providing the URL, the JSON package, and then getting back a response code and a status code so that we can track what actually happened in the middle tier. For larger files, so the previous screen was how I would approach it if it was 10 megabytes or less. I wanted to, just to make sure that we didn't run into problems with larger documents, I wanted to have a kind of a secondary option. And this is what I've put into place when that's the case. So when a file is uploaded, I'll be checking the size. And if it's larger than 10 megabytes, we're going to use a different method. And in this example, we're basically using a technique that is kind of like a web form, where you go to a page and you on a website and you do a file search and you pick a file and click upload. It's basically a web form, and you're doing a form upload with that. This is very similar. It's just that you're basically taking all of that logic and putting it into the header of the request. And so the first few lines of code were basically kind of marking a boundary and concatenating several blobs together. And the kind of the end game with all of that is to have a response header that contains the form data, the uploaded file, the name of the file, and the content type, and the encoding involved. And once all those blobs are concatenated together, you can then use that to set the request header. And then ultimately you make a call to the API using the send request with the post method. And again, we've got a URL specified, and then the blob that contains all of that information. On the API side, I have a method called document package, and here you can see for smaller files, I am getting a data store that I called document data. If you recall, in the previous slide on the client, I was assigning that key value to it, and then I'm extracting various pieces of information out of that. For instance, the document ID, the file name, and then the binary data, which at this point is encoded. So I'm using the .NET method convert from base64 to put that into a decoded a byte array. And then that byte array gets passed into a service method along with the name of the file and the ID. And that service method is called process document. So that method looks like this, and it ultimately takes the passed arguments and calls a private method called update document. And that private method does the heavy lifting in terms of the database operations. it will, by reference, return any error messages, and then write to a log, and then do some error checking and perform the proper returning the proper value that it needs to. Part of that process, in all that interaction between the controller and the service methods, ultimately it's going to check to see if a document exists. If it does, it will update the blob in the database. If it does not exist, then it will insert a row into the document header and the detail table. So in this particular case, with this client, they have a master and detail relationship in their documents. So in this particular case, it became necessary to do a check like that. But in either case, depending on how that's done, the API service logic will begin a transaction, execute the SQL, and in this case, the parameter string SQL is simply a delete from, or a update, or a select column, and so forth. Kind of basic operations. The service upload method. Now this is what we would do if the file is larger than 10 megabytes. So again, going back to a previous screen, let's say you choose a file and upload it. It's going to be kind of embedded in the request header. Here we're using some standard .NET functionality to basically set a path and a file name, and then creating a file stream, because we're going to be taking the blob of the binary data and writing that out to a file and then copying it to a specified folder. And once that's done, you can do a service method call to update document, and that's going to go out and actually grab that file, read it, and update the database. And then, of course, the corresponding error checking and return code as part of all of that. So that's kind of a quick walkthrough of the insert process. Retrieving a file, again, there's a Power Builder client aspect to this, as well as a logic on the server side. So in this case, getting a document, we kind of kick off the process by instantiating a REST client object, calling the send get request method with a URL, passing in the ID, and if all goes well, we're going to parse out the value of the binary data, and then decode that using base64 decoding. And if the file size is greater than 0, we're then going to do a file open, file write to create the file locally. And if that all goes well, then we're just simply going to pass that to the web browser control and display it. On the controller side, pretty straightforward logic here. So again, we're back in the API code. We are setting up a new data packer instance and calling the get document service method for that particular document, taking the blob data that's returned from that, adding it to the data packer. I'm also getting the file name out of the system and also appending that to the data packer. and then returning that back to the client. And that's where we get both the binary data and the name of the file on the client side. The corresponding service method for this is pretty simple, but the main thing I wanted to highlight here is that it's returning a blob data type, essentially, but Appian in their SnapDevelop documentation calls this the PB blob. And notice the return statement, there's a create method that goes along with that, and so we're simply creating a document from a binary data, putting it into a PB blob data type so we can read it, and then sending it back via the controller to the client. And note, this is part of the PowerScript.bridge NuGet package. So in order to take advantage of this, you would need to get that package from NuGet and install it. So emailing a file, the idea behind this is if you retrieve a document out of the database, you might want to then send that or forward it to somebody else. And so to utilize that, to set it up, what you need to do in this case, or what I did, and there are other tools that handle email in .NET, but I like to use something called MailKit. It's a package from NuGet that you can easily download and install. Once you have that, you can use the app settings JSON to define email settings. That would include the server name, the port, credentials, things like that. On the PB side, you can create an external data window as a broker, and that would just be a series of columns that you can populate, and this would include the CC information, the recipient, who is it from, BCCs, the binary data for the attachment that you want to send, the subject and body, and things of that nature. And in this case, this external data window, I exported that into SnapDevelop. So to send the email, you just simply populate a JSON package using the data store values, or again, that's could include the subject, body, recipients, and so forth. And then simply call the REST API. And in that case, that call, you would be sending the data store across the wire. And then once the call is made, you'd simply unpack that data and then process it in your email service. So this is an example of some code in the controller for the API called send document email. You can see that I'm unpacking a data store of email data, extracting individual columns or values for columns that are part of that data store. So the document ID, the file name, the binary data, the CC list and BCC list, if any, and so forth. And then lastly, taking that binary data and putting it into a byte array. And finally, just calling the service method that uses MailKit to send out the email. And again, that just has a list of parameters, the CCs, the BCCs, and of course the attachment. For the service method that actually sends the email, this is all .NET code, and it was easy to set up because there's many examples of how to use MailKit. But you can see that you're defining internet address list, building the CC list, the subject, setting the body content, You can make it plain text. You can make the body content in HTML. There is a add attachment option, and then you take all of that, all the as parts of the message, and then you use the builder to append everything to the message body. And then ultimately you're just calling an SMTP client, and all of the settings from the app settings JSON, like the server name and so forth, that's used to authenticate the call. And then if that works, ultimately the send goes out, and it will disconnect, and then hopefully the email will successfully go out. So I'm going to give you a quick demo of our proof of concept application to illustrate some of the things that I've been talking about. And so I'll pause here for a second and get that started up. So here's my document manager application. We saw a screenshot of this earlier, and it's got a number of buttons that perform different things: inserting a document, getting one, sending an email, deleting a document, and so forth. There's an interface for specifying the document ID, and a web browser control off to the left, and a MLE to show response values from the API as calls are made. So let's just start with a quick example. So I can type in a document ID, and that goes out and makes a call across the wire and pulls in the file name. And this is, in this case, this is a README document. And the second button here is get document. This is a pretty simple file, just 6 pages long, but mostly just text. You can see that the web browser was populated with all the data, and of course, once you have it here, you can do numerous things: rotate it, download it, print it out, zoom in, zoom out, and so forth. So I can simply change this if we want to look at a different document. And tab off that. And notice the file name changed, and I can click Get Document again, and this is an actual report from our client. And in this case, it's 3 pages long, but you can see some logos involved and so forth. It's a little nicely formatted report that shows up and renders well in the web browser control. Now I'm going to put in type in a different document number here. Here's a document that, notice that the file name is NA, and the response from the API was that it does not exist. So I'd like to use this particular example as a way of showing you how to insert a new document. So in this case, I'm going to click on this button, and it will go out and give me a file selection, and I can choose a sample PDF with images, and I'll go ahead and select that. And notice that the file name populated, and we got a response back. So the file size is almost 4 megabytes. If I click on the Get Document option, it goes out and pulls that file, and you can see that there's a lot of text with embedded images. This time we have 10 pages, so that's a good sized document. I can also click the delete button. that's going to clear everything out. I got a response that it was successfully deleted. So now let's pull up another one here. And again, we saw this one earlier, but I'd like to show you how the email functionality works. So in this case, I can click on email, and I got a response back that it was successful. So let me switch gears here, and we'll pull up Outlook and just make sure that email did in fact get sent. Here I have Outlook open, and you can see I got an email dated today at 5:31, and it's from the Enforce API, and it has an attachment for the Brady report that we were looking at earlier, with some generic text in the body of the message, and of course I could open that up and view it. So the email portion of this of the API is really easy to implement and is pretty slick in how it works. So that concludes the demo portion of the presentation. Let's move on. A big part of this, of the reason why we're developing this, is, and I spoke to this earlier in the presentation, is that performance was an issue in the way the client was getting these documents and inserting them, updating them in their current system. And in my POC application, I added a little metrics checkbox. And so what that does is when I either insert or retrieve a document out of the database, I'm essentially making a call twice. It's doing it the new way, and then it follows that up by using the existing functionality that they have, and then I'm tracking the length of time that it took to do each operation. And so in the screenshot on the left, notice that the response there, it says API get document, client get document. So the API is self-explanatory. That was the first call I made, and notice that the retrieval of the document took 5 seconds, and then after that is the number of bytes. So that was a 10 megabyte file approximately, and then that was immediately followed by the same call but using the client with the existing code, and that's simply you making an embedded SQL call to select blob and then display that to the user. And doing that took 30 seconds. So that's a significant difference. That's essentially the retrieve 6 times faster with the API and a 10 megabyte file. Another example on the right hand side is using about a 4 megabyte file. This was doing the insert, and it was about almost 3 times faster with the API and a 4 megabyte file. And it seems like you get the bigger the file, the better the performance. So to me, it's pretty significant, and I think is kind of a real win for the client in terms of implementing this solution once we finish it up and do all the validating that we need to do. So that is my presentation on document management with SnapDevelop, and I hope this was informative and useful, and that there are some tips, tricks, ideas that you could possibly use in your work with PowerBuilder and SnapDevelop down the road. So I'll open it up for any questions that you might have, and thank you very, very much for your time.